Look down at your hands. This physical form is built from atoms forged in dying stars. Yet, the mind controlling those hands is the single most complex phenomenon we know of. We are biological machines that learned how to ask why. This is the story of that impossible evolution. Intelligence is not a given. It is an incredibly expensive metabolic luxury. For 99% of life on Earth, simply reacting to immediate stimuli is enough. So, what unique environmental and selective pressures forced certain lineages to develop planning, awareness, and abstract thought? To track its origin, we must first redefine it. Intelligence isn't just consciousness. It begins as optimization, the ability to calculate the fastest path to resource gain while minimizing risk. Even early prokaryotes displayed rudimentary chemotaxis, a bias toward efficiency. The critical leap happened when complexity demanded communication beyond simple chemical signals. Simple life forms like cnidarians developed decentralized nerve nets. Their intelligence was distributed, reacting locally but lacking a central command center. Around 550 million years ago, bilateral symmetry became the evolutionary standard. If an organism moves predominantly forward, it needs sensors at the front. This necessity instantly placed all key sensory data in one region, creating the requirement for a head, and thus a brain. The Cambrian explosion transformed simple survival into an existential arms race. New predators required new defenses, and the best defense was anticipation. Intelligence became the ultimate selective filter. Those who could anticipate the predator survived. Those who couldn't vanished. Vision, specifically, demanded immense processing power. Calculating trajectory, distance, and threat level in real time is computationally demanding. This metabolic investment in perception turbocharged the expansion of the brainstem and basic memory structures in vertebrates. The arrival of vertebrates introduced the tripartite brain structure, a foundation that optimized motor control and complex reflex behavior. The basic survival toolkit was finalized. But true, flexible problem-solving was still hundreds of millions of years away. After the great reptiles fell, mammals took center stage, bringing a critical innovation: the neocortex. This layered structure allowed for vastly improved predictive modeling, long-term planning, and, critically, the ability to manage complex social dynamics. The social brain hypothesis suggests intelligence expanded specifically to handle complexity not of the environment, but of the group. Tracking hierarchies, managing alliances, and predicting the actions of dozens of individuals requires exponential cognitive horsepower. The development of the prefrontal cortex, or PFC, marks the final great structural change. This is the seat of executive function, the ability to suppress instinct, delay gratification, and project consequences far into an imagined future. Enter the hominids. Bipedalism freed the hands for tool use. Tool use demanded abstract conceptualization. Abstract concepts demanded complex language. This created a rapid, self-reinforcing cognitive feedback loop unlike any other lineage on Earth. The mastery of fire provided safety and, more subtly, dense energy. Cooking meat meant we could outsource digestion, freeing up massive amounts of metabolic energy previously dedicated to gut maintenance. That energy was immediately rerouted to the hungry, expanding brain. Then came the symbol revolution roughly 70,000 years ago. We stopped just reacting to the world and started describing it. Language wasn't just communication. It was an external, collective hard drive for knowledge, allowing ideas to survive the death of the individual. If our intelligence followed this linear path, why are there outliers? The octopus, possessing a decentralized nervous system and evolving high complexity independently, showcases convergent evolution. It solves the intelligence problem using a fundamentally different architecture. This radical intelligence comes at a terrifying cost. The modern human brain uses 20% of the body's entire metabolic energy, despite being only 2% of the body mass. We are living beyond typical evolutionary means, fueled by constant resource consumption. The story of intelligence is fundamentally the story of minimizing uncertainty. From sensing a threat 600 million years ago to predicting global climate change today, our core function remains the same: survive the future by analyzing and manipulating the present. We are now accelerating our own evolution through technology. Artificial intelligence and genetic engineering force us to ask, is humanity merely the biological incubator for the next non-carbon-based form of cognition? Are we the necessary but temporary scaffolding? Tracing this 3 billion-year lineage confirms one thing: the universe rewards those who adapt, not those who merely exist. If we forget the lessons of scarcity and selective pressure that defined our climb, what intelligence, biological or otherwise, will ultimately survive our era? Let us know your interpretation in the comments below, and subscribe for more deep dives into the mechanics of reality.